Hi everyone, we're going to start basic trig identities, doing 4 problems, 2 that involve trig ratios, and 2 that involve Pythagorean identities. Basically, we want to work on one side of the equation and make it look like the other side of the equation. And we can't cross over or do anything like that. You can't cross multiply. If you want to, you can work on this side. We know that cotan of theta, if you do your trig ratios, is cosine of theta over sine of theta. That might help if you're not sure what that looks like yet. And we know that cosecant of theta is 1 over sine of theta. So we're going to multiply that by cosine of theta. I'll go ahead and put that in fraction form. And that gives me cosine of theta over sine of theta. So we indeed match these two here. And you could do that. You can work on one side and the other side and make a match. Or if you already knew what this is, then you could just write this as cotan of theta. Okay, and then so you have cotan of theta equals cotan of theta, which is kind of what you want to balance. All right, and the same thing's going to happen here. I'm going to write this as 1 over cosine of theta times sine of theta. This is your ratios again. And that equals sine of theta over cosine of theta, which equals tan of theta. So I got this side to equal that side. You could have done it that way. Or you could have rewrote this and you could have written sine of theta over cosine of theta equals sine of theta over cosine of theta. Which I wouldn't know why you'd want to do that. It's a little harder that way, but it's a lot more writing, let's put it that way. Okay, the next two we're going to do is Pythagorean identities. Students tend to have a problem with this, and the thing you need to know about this is we just write the square there by convention. You could actually write this and put the square there. And we want it to equal this side. So when you square out the negative, it's positive. So you're going to get 1 plus tan squared of theta. And this is your identity, Pythagorean identity, because we know that equals secant squared. Now I just want to talk about this for a minute. This right here is your identity, and I'm going to show you where that comes from. It comes from the fact that sine squared of theta plus cosine squared of theta equals 1. Now if you divide, let me do a different color, divide everything by sine squared of theta, I should have did cosine, sorry. Let's divide everything by cosine. Cosine squared of theta, cosine squared of theta, cosine squared of theta. This equals tan squared. This equals 1. And this equals secant squared, theta. And then you just switch these two around. So 1 plus, it doesn't really matter. You don't have to do that. But so if you ever forget this identity, which is kind of easy to do, just remember that it's based off of this one here. Okay, the next one's the same thing. I'm going to go ahead and put the square on this side, and you square out the negative, you get 1 plus cotan squared of theta, and this equals cosecant squared of theta. So it's basically an identity, Pythagorean identity. And I'm going to go ahead and show you y again. It's based off, it's what I was trying to do the other video. It's based off that, and we're going to divide everything this time by sine. So this equals 1. This equals cotan. And this equals cosecant. So again, if you forget this identity here, just remember all you have to do is it's derived from the basic identity sine squared theta plus cosine squared theta equals 1. Or you could say y squared plus x squared equals 1. Okay? Thank you. The next ones we're going to do involve getting a common denominator on the identities. Thanks and have a nice day. Bye-bye.